Okay, so in this video we're solving rational equations. Essentially a rational equation is just a fancy math way of saying our equation has a fraction in it. Okay, so when you see the word rational, that means fraction. So we're looking at fraction equations. Okay, and the first type is when you have only one fraction per side. All you got to do is cross multiply. So this is the easiest way it gets. Again, like we said in the previous video though, when you're talking about any rational equation, you have to watch out for extraneous solutions. So remember that and go back and check your answers. So only one fraction per side, that means I can cross multiply. So literally, I'm going to do this. 2 times negative 11, I'm going to just follow the arrows, is negative 22. Follow the arrows, 5 times x is 5x. So now I want to solve this. So divide by 5. So x equals negative 22 over 5. Okay? Now, again, since it's a rational equation, I want to go back and do my scratch work and plug into the original problem. It's always important you go back and plug into the original. Don't plug into your simplified version. Always plug into the original when you're checking for extraneous. So, scratch work, I have 5 halves equals negative 11 over, I'm plugging in, so I'm going to put it in parentheses, negative 22 over 5. Okay, and I just want to make sure that I do end up with what I'm supposed to. So, essentially, this thing here is supposed to become positive 5 halves. So I'm going to type that in my calculator exactly the way it looks, parentheses and everything. So I have negative 11 divided by, parentheses, negative 22 divided by 5. And I get 2.5. Well, let's turn that into a fraction. And I get 5 halves. 5 halves equals 5 halves. So this is a valid solution. I got exactly what I was supposed to get, so it's not extraneous. Okay, a little bit more complicated here. However, I don't care how complicated it is. One fraction per side, we just need to cross multiply. Okay, so I'm going to go from bottom to the left first, so just follow the arrows. So 2 times x minus 1. And that's supposed to be equal to 1 times x squared minus x. Okay, no problem there. Now, obviously, I have distributive property on both sides, so I'm going to take care of that. So, distributive property. So, I have 2x minus 2 equals distributive property on the right, x squared minus x. Okay, and since I have an x squared, what I'm going to do is get everything on the same side. So, I'm just going to say plus 2 minus 2x minus 2x. I'm doing this all in one move. If you need to split it up into 2 moves, that's fine. But essentially, negative 2 and positive 2 cancel out. Positive 2x and negative 2x are going to cancel out, just leaving me with a 0 on the left. And x squared minus 3x plus 2 on the right. Again, I just moved everything over, combine like terms. X squares go with x squares, regular x's with regular x's, regular numbers with regular numbers. Now what I want to try to do is to factor. Okay, again, if your factoring is bad, refer back to the videos in earlier chapters because you really need to know how to factor. So if I factor this, I believe this is going to factor into x minus 2 and x minus 1. Let's do our double check. First off, negative 2 and negative 1 multiplied together is positive 2. Now if I add those together, negative 2 and negative 1 is negative 3. So those two do work. Now I have everything equal to 0, so that means I can use the zero product property, which lets me split this up into 2 smaller equations. So 0 equals x minus 2 and 0 equals x minus 1. And what we want to do is solve each of these equations now. So just say plus 2. So x equals 2 and then plus 1. So x equals 1. Now, before I circle those and say I'm done, I need to go back to the original problem, do some scratch work. Everywhere I see an x, I'm going to start off by plugging in t for my scratch work. I'm looking for extraneous solutions because I have a rational equation, okay? So I have 2 over 2 squared minus 2 equals 1 over 2 minus 1. Notice that when I plug in, I always put in parentheses wherever I plug in. That represents that I put my answer in there. I advise you to do that as well. All right, so let's clean up one fraction at a time. So 2 is going to stay on top. 2 squared is 4, so we have 4 minus 2. Over here, 2 minus 1 is 1. All right, so now we just want to clean this up. 2 over 4 minus 2 is 2, so 2 over 2 is supposed to be equal to 1 over 1. And obviously 2 over 2 is 1, so x equals 2 is a valid solution. Okay, and now we just want to do scratch work, same idea for x equals 1. Okay, so just plugging in, scratch work part 2, so 2 over 1 squared minus 1 equals 1 over 1 minus 1. Okay, let's clean up one fraction at a time. 1 squared is 1, so I have 2 over 1 minus 1 equals 1 over 0. Well, I have 2 over 0 here. All right, so if you learned anything from your previous classes, you should know that when you have a fraction, you can never, ever, ever, ever have 0 on the bottom of the fraction, ever. So as soon as you see 0 on the bottom of the fraction, that means x equals 1 is extraneous. It's a false solution. You don't want it, throw it out, pretend it doesn't even exist. So even though we came up with 2 solutions, only one of them, x equals 2, ended up being valid. Okay? Sometimes when you have rational equations, you're not going to have just one fraction per side. You might have multiple fractions per side like we do in this example. First off, anytime you see a regular whole number like this, it can always be written as a fraction by putting a 1 under it. So even though I have one fraction on the left, I have 2 fractions on the right. So before I can do anything, I must come up with what's called a common denominator. When I come up with a common denominator, I'm going to multiply 3 times. I'm going to multiply across the bottom. I'm going to multiply from the bottom to the top left. And I'm also going to multiply from the bottom to the top right. So that's how we're going to do our common denominator. So this is just going to be scratch work over here on the side. So I had 7 over 1 plus 10 over x minus 2. And I'm just going to follow the arrows. My first arrow in yellow, okay, my first arrow in yellow said multiply on the bottom, so I had 1 times x minus 2. Now following the purple arrow from bottom to top left, I have 7 times x minus 2. Follow my arrow bottom to the top right, I have 1 times 10. Notice that I had plus in the middle, but I haven't done anything with it yet. Whatever symbol is in the middle, you don't do anything until the very last step, which is just put it in the middle. Whatever's in the middle, if it's positive or negative, put it in the middle. So here, positive. Now I want to clean this up as much as possible. So I have distributive properties several places. So distributive property here. 1 times 10 is just 10, so no big deal there. And distributive property on the bottom. So let's take care of the top. So I have 7x minus 14 plus 10. Taking care of the top. On the bottom, distributive property, I have 1x minus 2. Now I want to clean up as much as I can on the top. So negative 14 plus 10, that's negative 4. So 7x minus 4. And then on the bottom, I just have 1x minus 2. So all of this, my 2 fractions on the right-hand side of my original equation became 1 fraction because I came up with my common denominator. You must do this part first if you're going to solve a rational equation by hand that has more than 1 fraction on the side. So now we can finally rewrite our original problem as 5x over x minus 2 equals 7x minus 4 divided by 1x minus 2. Okay? So now what we want to do is, we have 1 fraction per side, so we're going to cross multiply, just like we did earlier. So working my way up, I'm going to go from the bottom to the top left. So I have 5x times 1x minus 2 equals, bottom to the top right, x minus 2 times 7x minus 4. Okay? Now, obviously over here on this side I have distributive property, so let's go ahead and take care of that. So I have 5x squared minus 10x. But over here on this side here, it gets a little complicated. So I might want to do some scratch work, which I am going to do in blue. just over here on the side, and I'm going to use the box. Some of you like FOIL better. If you like FOIL better, then go for it. But I got x minus 2, 7x minus 4. All right, so 7x times x is 7x squared. 7x times negative 2 is negative 14x. Negative 4x. And then positive 8. So combining my terms, I have 7x squared minus 18x plus 8. All right, so that means over here, that was just, again, all of this on this right-hand side is scratch work. So this is equal to 7x squared minus 18x plus 8. What I want to do now is, again, I have x squared, so I want to get everything possible on the same side. So I'm going to say minus 5x squared minus 5x squared. I'm going to do this in 2 steps just because it's so much stuff. So negative 10x equals 2x squared minus 18x plus 8. And then finally, I want to add 10x. So 0 equals 2x squared minus 8x plus 8. Okay? So now I'm going to factor. I'm going to use the bottoms up method of factoring. If you don't remember that method, then you should go back and look at the previous videos. Hopefully that this factors out. First thing I notice is that I have a factor of 2 that'll come out. So I'm going to pull that 2 out. So I have 0 equals 2 times x squared minus 4x plus 4. And if I divide by 2 on each side, I still have 0 equals x squared minus 4x plus 4. Okay? So if I factor this, 0 equals x minus 2, x minus 2. I want to do my double check. Negative 2 and negative 2 multiplied together is positive 4. Adding negative 2 plus negative 2 is negative 4. So those two do work as far as factoring goes. Now what I want to do is use the zero product property. Since it's all set equal to 0, I'm going to split this up into 2 smaller equations, x minus 2 and 0 equals x minus 2. Add 2 to both sides. So x equals positive 2, and same thing here, plus 2, plus 2. So I have x equals positive 2. But since we started off with a rational equation, we need to go and plug in a 2. I'm not actually going to write that out this time. Let's look at the bottom though. We know that if we have a problem, we can never have 0 on the bottom. So what I'm looking at is when I plug in my answer of x equals 2, will I end up with a 0 on the bottom? If yes, then the answer is extraneous. If no, then everything should be okay. Let's look at the first fraction of my original problem. If I plug in a 2 here, 2 minus 2 is 0. So automatically, I have a 0 at the bottom of the fraction. So that means x equals 2 is extraneous. Again, that's because x equals 2 makes a 0 at the bottom of my original fraction. You can't have that, no matter what. So it's extraneous, so you throw it out. And guess what? X equals 2. Also extraneous. So you throw it out. So what that means is no solution at all. Our 2 possible solutions were both extraneous. We had to throw them out because it made 0 on the bottom of our original problem. You can't do that. Nothing's left as a possibility, so it means no possible solution. And that's it for this video. Now, I understand rational equations are a lot of scratch work. Might be a little overwhelming for you. It's going to take practice. 2, remember, you can always graph, okay? So, what I suggest though is get 1 fraction per side, then cross multiply, then graph. Otherwise, if you are going to graph from the very beginning, remember, if you see more than one thing on top or more than one thing on the bottom of the fraction, you need to put parentheses around it like we discussed earlier this semester in class. If you don't, it's not going to graph correctly. So just watch out, okay? Let me know if you got questions.